let's get started here in a second. I know we'll probably have people jumping in as we go. So thanks everyone for joining. This will be a really special series that we're kicking off called In the Lab, focused on engineering and platform updates and upcoming milestones and different things that happening with the Ava Labs engineering team. And then in the future, we'll probably be bringing on some other special guests as well. But, everything's going to be led by the Ava Labs engineering team. So I'd like to introduce them real quick, and then we will get started. So the first person I'd love to introduce is Patrick O'Grady, VP of Engineering at Ava Labs. Patrick, you want to give a quick hello?
Yeah, thanks, Kyle. Nice to meet everyone. I'm Patrick. I'm the Vice President of Engineering here at Ava Labs. I'm the one who looks at Twitter, looks at everything everyone's doing, and turns that into our roadmap of what we decide to work on here to help the Avalanche ecosystem. It's been great to get to know a lot of you, and for people that I haven't met yet, really looking forward to get to know you better.
Awesome. Thanks, Patrick. And then we have Stephen, our Chief Protocol Architect. Stephen, want to give a quick intro?
Hey, thanks. Yeah, so as you just mentioned, my title is Chief Protocol Architect. My name is Stephen Buttolph. I've been working on the Avalanche Go implementation for around 3 years or so. So pretty much head down, focusing on the tech for the platform side. I don't check Twitter too much, to be perfectly honest. But yeah, happy to be here. So yeah.
Awesome. Well, thanks both of you for joining us. And so yeah, In the Lab is going to be a great discussion series. So I'll let you guys take it away from here.
Great. Thanks, Kyle. Yeah, so welcome everybody to our first episode of In the Lab. So first off, I'll start off with the reasoning behind this, and Kyle touched on this briefly. But if for many people they recall, I used to write a at-length Twitter thread of exactly what we were doing on the engineering side each week or every other week with the highlights of our major accomplishments across our entire engineering here at Ava Labs. And so as many people know, we maintain Avalanche Go, we maintain Coreth, we have a series of API nodes, we have a wallet. There's a variety of like client SDKs we operate or maintain. And over time, the team started doing so much that writing these threads and pulling everything together started to take me quite a bit of time. And to keep focus on shipping and keep focus on pushing out the releases we really cared about, I kind of took a pause on writing those threads. But the community, rightly so, was very curious what we were working on and what we were focused on. So I created or proposed that we create a Twitter space instead to cover the major development items that we're focused on, as well as to outline some of the things that we're thinking about. And so this chat is supposed to be a very technically focused chat, very specific to more of the engineering and in-depth developer milestones rather than maybe the high level, business development or like marketing related goals. So that we can both enlighten folks into what we're working on, how our platform works, as well as hopefully encourage more folks to get involved with contributing to Avalanche and building on top of Avalanche. We think this will become an even bigger topic once, as the subnet narrative continues to grow and people will start to build, more interesting custom virtual machines that require a lot of technical interaction or may have very technical questions. So just want to get people familiar with who we are so we can help them out. This session is focused first on platform. So Stephen here is our technical lead of our platform efforts. So that's Avalanche Go development. He's the guy that, if you're looking to see who really took it from zero to where we are now, Stephen's the guy you're going to want to talk to. And so thought rightly so, bring him on. He has, tons of great ideas of, everything obviously that is a great explainer of what we've done thus far, as well as has an amazing handle on where we're going from here. And so with that, I think I'll turn it over to him and we'll start off just with getting into the basics of, first of all, covering how Avalanche Go is structured and then going from there to where we're going after that. So Stephen, with that, I'll turn it over to you.
Yeah, no, I just want to clarify one quick thing. While I definitely put a lot of work in on this stuff, I don't want to take all the credit. I've had a lot of good ideas, but I've also had a lot of bad ideas. So a lot of the rest of the amazing engineers, some of which are eavesdropping on this call, are have really helped out. So I don't want to take more credit than I feel like I'm due. But that being said, yeah, I really want to dive in on kind of the base idea of kind of Avalanche Go and how it's set up. So um, back when we were kind of first working on setting up the platform side and designing it, we were working with this new innovation on the consensus side, which is the of course the Avalanche consensus mechanism. So that we knew that was going to be kind of like the centerpiece of at least our original rollout, but we didn't necessarily want to just push out kind of just another chain with a slightly modified consensus algorithm. Okay, slightly modified consensus algorithm. That's an understatement. But like, anyways, with a new consensus algorithm, and so we also came up with this kind of idea of these subnets. And so the way Avalanche Go is structured is really meant to be very modular to support this eventual kind of subnet architecture. So the way that Avalanche Go is designed is kind of stuck into these four kind of major areas, one of which is the networking. Then there's the consensus side, there's the VM side, and then there's the database. So these are kind of like the four kind of major areas of interest. And then there's a decent amount of glue work and things like APIs and stuff. But those are kind of the things that I consider like the heart of Avalanche Go. And once we kind of started digging in on the consensus side in the Avalanche paper, by the way, Patrick, feel free to cut me off at any time if I start rambling too much, because I can talk about this stuff for days.
Those are the best. Those are the best conversations. Yeah.
But yeah, so on the consensus side, we first ended up implementing Avalanche as a DAG following the Avalanche paper pretty closely with a couple small tweaks. And we quickly realized that we wanted to additionally have a new a module for linear chains. So as powerful as the DAG is, the core limitation of it is that you can either provide a partial ordering, or you can try to stick a total ordering in there by essentially limiting to one UTXO per state. But what ends up happening then is you end up having some issues with non-transitive conflict support and things like that. So we ended up implementing Snowman as kind of a second consensus instance. It is a strict subset of Avalanche, but it allows you to do a bunch of optimizations on the consensus side around the use of transitive conflicts. By transitive conflicts, I mean that if two blocks are issued at the same height, you know that they conflict. And if a third block is issued at the same height, all three of them conflict. Whereas in Avalanche, if you have multiple input UTXOs, the transactions can actually not form transitive conflicts, where transaction A, B, and C, like A might conflict with B, B might conflict with C, but A doesn't actually conflict with C. So digging into Snowman, we ended up implementing that out, and that kind of fleshed out like two different components of the consensus infrastructure, and that ended up introducing two different interfaces for virtual machines to plug into, one in the Avalanche consensus and then the other with the Snowman consensus. So in our primary network, which I'm going to dig into a bit on how the subnets are structured as well, we have three chains, which is the P chain, the C chain, and the X chain. So the P chain and C chain both use Snowman, so they implement the VM specification for Snowman blocks. And the X chain is a DAG, so it actually implements the DAG VM interface. So that's kind of how the separation works there. So we actually, when a node is running the primary network without any additional subnets, it's actually running three different consensus instances. It's running the Avalanche consensus instance for the X chain. and it's running 2 instances of the Snowman consensus engine. Um, so that's how Avalanche Go ends up kind of managing the consensus side of the of those 2 implementations. So there's been a lot of talk about Frosty consensus, which is a improvement that we're planning on making on Snowman. We've been focusing a lot on Snowman improvements just because of kind of how important these linear chains are, both in our system now and kind of in our future plans. So with Snowman++, we improved Snowman with reducing contention, and with Frosty, we'll be further improving some of the kind of theoretical bounds of the native Snowman consensus. So those are that's kind of, I know again I'm just spewing, but those are the kind of highest level, not super high level at some points of the areas with consensus. And
Sure.
I don't know, Patrick, if you want to guide the conversation towards an area you want to talk about a bit as well.
Yeah, I mean, I'll hop in here first and kind of reiterate where we're coming from here. So I think to explain some of these stuff that we've been working on and where we plan to go, it's important to have a shared understanding of where things are currently, currently set. And so the explanation you gave around the consensus and how there's 3 separate chains running 3 separate consensus instances is important, I guess, in terms of how to think about some of the other stuff we'll go into. And I think actually a really good segue there is probably maybe diving in more on how Core ETH and the Cchain fits in more specifically to this. And I think some people have wondered how close does Avalanche go to a fork of like Geth or like some of the other EVM based projects that are running on various consensus parameters. And I was maybe cover quickly too how we compare there, and then I'll dive into some of how Apricot Phase 5 changes this topology.
Cool. Yeah. So that's a good question. I've seen that get thrown around in the Discord and on Twitter a little bit. So Avalanche Go is a fully new client implementation. So essentially, we started from scratch, implemented our own networking stack, implemented our own consensus stack. The VM interfaces are totally separated and totally built by us, like the Cchain and the P-chain. Now, the interesting thing about the Avalanche, another interesting thing about the Avalanche Go structure is that the VMs aren't necessarily all native VMs. So the P-chain and the Cchain are inside of the Avalanche Go repository, and so all of that code is just kind of there. But VMs are also able to dynamically be added to Avalanche Go. So you can set up what we call plugins to run with your VMs. So the Cchain is actually using Core ETH, which is a separate repo that we manage. And Core ETH is a fork of Geth, which defines the VM for the Cchain, so essentially the EVM. So these plugins are essentially used to just define the state transitions of blocks and also to be able to query the state. So Avalanche Go is totally separate from really anything Ethereum, but the Cchain specifically is the fork. So that's kind of how that structure works, and that's how Avalanche Go ends up being so extensible. The Cchain is probably the chain that most people know of when they think of Avalanche, just because that's where a lot of the utility is right now and a lot of the operations. But that's actually implemented as a plugin. The Cchain is not treated special in really any way for Avalanche. So basically, anyone could implement something as complex or more complex than Core ETH. So
I think the thinking there really was, all right, if we are going to push hard on this generic VM concept, if we can implement an EVM compatible chain using our plugin, interface, we should be able to implement almost any virtual machine using that plugin interface. And over the last, since mainnet launched last year, we've been focusing on improving that experience both from a UX, like developer perspective, as well as from a performance perspective of how do you pipeline things over gRPC, how do you cache better, how do you reduce the communication overhead of running these dynamic virtual machines. And I think that the continued growth of the Cchain has continued to push us further along that road. But as Stephen mentioned, it's totally separate, and so you could just as easily take any number of the popular virtual machines people are developing in and run them just like you would core ETH. So you could take a Cosmos virtual machine, you could take a Solana, you could take a generic Wasm or Rust virtual machine and just run it just like you would core ETH as a separate virtual machine. So some people ask us, where technically we go from here, and at least on the virtual machine design front. And some people have asked us, what sort of reference virtual machines do you have in mind? What sort of additional things are you going to put out to help people build their own custom virtual machines? And our answer typically, and this is where we are going, and I'll touch on this towards the end of our conversation around what we have in store here. But generally speaking, we view ourselves as someone that provides, very high fidelity examples of what you could try to do with these virtual machines, such that you could take them and build as you saw fit on top of this interface. So we would, roll out different examples that have complicated state access or like complicated transaction processing or are optimized for some type of transaction processing, and then leave it to people to extend where they could see that going. But generally speaking, I think that's one of the largest or most interesting technical directions is if some project has a really cool virtual machine, we'll take it off the shelf and say oh, what if we could run this on Avalanche, or if people want to run subnets with different virtual machines. So unlike other folks where you're very tied to a specific virtual machine, or you're very tied to a specific abstraction, we feel like there's a lot of flexibility there with how we can approach future development. And as we continue to get these next few deliverables out around subnet usefulness or UX in terms of permissionless subnets and some of the cross subnet transfers, we think this will become a very interesting and active path of development for us, because it just seems so limitless in terms of the opportunities that you could start to pursue there. I think go ahead.
I was just gonna say, just jumping in real quick there, definitely one of the things that I was personally inspired by with kind of this plugin architecture was looking around at some of the kind of main networks out there, and some of the ones that I personally like a lot are things like Monero or Zcash, and things they're really fascinating, but their core innovation is focused on the VM side. Now, I don't want to say all of their innovation is on the VM side, because there's probably things that I don't know about there, but a lot of things like that came out of some of the early network updates or the network forks were some cool and super super fascinating changes at the VM level, but a lot of them just kind of copy pasted what Bitcoin had with proof of work, block management, Nakamoto consensus. And with this, we can kind of abstract all that away. They don't have to deal with the consensus. They don't have to deal with the networking. They don't have to deal with any of this stuff. They just have to deal with kind of what their core innovation is. And I think that the innovation space in the VM land is so rich that there's really not going to be someone that implements some killer VM that just kills everything. It's this is the one VM now. People are always going to want to make their own innovation. They will want to have their own tweak, their own special case. And so I think that that's kind of what we're focusing on with these plugins and these subnets, is to make it easy for people to iterate and push out the innovations that they have. So just want to throw that out. Yeah.
Cool. Yes, I mean now that we have some shared understanding of the basics, at least for some people that maybe aren't as familiar with the technical deep dive here on Avalanche Go, the platform. Let's now take a turn into talking about Apricot Phase 5 and what we put out last week. To bring it more more current in terms of the conversation we're having here. So as you know, if you follow me on Twitter, you'll see I tweet about subnets all the time. So everything we've talked about so far is more or less a regurgitation of what I've probably already said. But let's go into Apricot Phase 5 now. So last week, I think on Tuesday or Monday, we put out the Apricot Phase 5 pre-release. That activated on Fuji successfully and then released the code for the Apricot Phase 5 production release, which activates on mainnet on Thursday at 1 p.m. Eastern Time. So if you haven't updated your validator yet, or you run a node for some other reason, make sure to do that. Otherwise, your node may fall behind after the activation time. So just a quick reminder there before we dive into a conversation around what that includes. So first off, I wanted to cover some of the atomic memory improvements. But before we do that, Stephen, I don't know if you want to give a quick understanding of what atomic memory is and how that fits into the primary subnet architecture and what that means.
Yeah, absolutely. So as I alluded to a little bit earlier, we have these three different chains, right? The X chain, the P chain, and the C chain in the primary network, and also each of those has their own fully separate consensus instance. So there isn't like one consensus instance for all of these chains. It's really three isolated consensus instances. And so one thing that ended up being like a question of how are we gonna iterate on this was, well, if I have assets on, say, the X chain, how am I going to move those assets to the P chain or the C chain? Now, some first kind of ideas were saying, well, this is all just kind of the same system, so just have the P chain try to like spend a UTXO on the X chain. But the whole point of consensus is to make sure that the state changes that are being performed are valid state changes. And so you would run into a problem of, well, there might be a P chain block that's trying to consume some X chain UTXO where an X chain transaction is also trying to perform that. And you would have to perform consensus on which of these operations to actually end up accepting. But if we wanted to, fully isolate these consensus instances, then that doesn't work anymore. So what we ended up figuring out how to do was saying, well, what we can do is rather than just directly consuming these UTXOs, we can kind of pass the UTXO from one chain to the other. So this is why we have this import-export transaction. So what ends up happening is the X chain will essentially say export a UTXO to the P chain, and that will mark that UTXO as being able to be consumed by the P chain and not by the X chain. And so now all of a sudden the onus is purely on the P chain to consume it with an import transaction. And that ends up circumventing this like need to perform consensus between the two. It actually ends up performing a kind of interesting partial order between the two chains of their order of operation execution, which is totally fine, but it is interesting. And so the actual way that is structured in the code is through this kind of shared memory module. So all of these VMs, when they start up or when a chain starts up, they're provided, basically a partitioned section of the database that they can modify however they want, which is how we essentially get this like isolation amongst the VMs. So the P chain or the X chain couldn't just like directly write to that shared that database, because then there's going to be issues with failure isolation, and we just didn't want to deal with that. So we essentially ended up making a reliable queue in the database layer with a new partition between these chains. So the X chain and the P chain essentially end up sharing this reliable queue to be able to send these UTXOs or messages or whatever you want between them. And so And so that is what we call this atomic memory. It's really not a great name, to be perfectly honest. It's shared memory in some other comments, yeah. So that's the basis for how atomic transfers works. And a key portion of how they're currently implemented is in order to do this partial ordering and not break anything. It is extremely critical that the validator sets are equal on both of those chains. So when we end up extending this with cross subnet transfers, then we'll loosen that restriction. But as it is currently, the cross chain transfers go like in the same subnet, basically, which is the validator set. So touching a little bit on what the actual improvements were with AP5, AP5 introduced two kind of main improvements on shared memory. One was that multiple operations can happen on shared memory at the same time. And what I mean by the same time is in the same block. So on the P chain and on the C chain, we've enabled multiple like atomic transfers to happen in the same block, which was previously a little bit difficult just with kind of how the shared memory was structured. We ended up needing to kind of finagle a little bit on the database side there. But then the second key improvement was actually enabling this P2C atomic transfer. So on the shared memory side, those were kind of the main improvements. So now we don't have to go from like P to X to X to C. We can just go direct to P to C. So
yeah, the two things I'll touch on there. One, with the P2C Direct, this has been something that people have complained about for a while. I think it was less of a problem when most exchanges were integrated on X because P-chain was just one step away, so it wasn't too big of a inhibitor. But then once most exchanges started to really integrate with the C-chain more so, especially Coinbase, it then became quite a burdensome experience to actually move from whatever address you withdraw to all the way to the P chain to actually stake. So you may have felt this, but it is the case as well that many integrators felt this. And so when talking to them about like, hey, would you ever consider starting to stake on Avalanche or making it easy for your customers to stake on Avalanche, the response was always, well, then we have to index the P chain, we have to index the X chain, and we have to index the C chain. And because the X chain is a DEG, many integrators were not able to do that within their existing systems and require a lot of engineering work. So by being able to bypass the X chain entirely, just to go directly from C to P or P to C, it opens up the door for other integrators that were previously prohibited or didn't feel like it was a good idea, could now actually integrate some staking flows. So we hope to see that, and I think we've shared that message loud and clear for anyone that has been considering it. So hope to see some progress there. On the multi-atomic front, just to reiterate, a lot of people, at least during times of a lot of traffic, when moving from the X to the C or between P to C or whatever they were doing, sometimes ran into a few errors on the wallet and would have to like exit out of their wallet and re-sign in to try and get a transfer through from the P to the C. For the most part, this was actually due to the backlog of transactions that were still processing on C-chain import or C-chain export. So as Stephen mentioned, there were some database constraints that we had to kind of work around. But for the most part, any C-chain block could only ever contain one atomic transfer. So if you and 100 of your closest friends decided all at once that you wanted to move funds from the X to the C or C to P or whatever, you'd more or less be in line, fee-sorted line for actually being executed. And if blocks are produced every 2 seconds on average, you could end up waiting quite some time to actually be included in a block. Up until September or October, this wasn't really a concern, just because of the volume of atomic transfers was somewhere around. It wasn't really a concern, but over the last month and a half or so, we've seen this amount of cross-chain activity increase dramatically, such that you may see runs of hundreds of blocks all containing an atomic transfer in them. So it became pretty clear that this was an area that we really needed to optimize and really remove that bottleneck, given that there wasn't really any load concern with that bottleneck. It was more so just legacy code that we needed to update. So those were the two primary things we were targeting with AP5. And then I think the one that a lot of people have also asked about is changes to the Cchain fee algorithm. So this has particularly come up because of the increase in usage on the Cchain, and I think generally a lot of people saw surges in the Cchain fee over the last week or 2 weeks that were unlike how they had kind of learned how Avalanche had worked and interacted with it. They were used to paying almost 99% of the time a fee around 25 nanovox, which is the minimum fee that was set in Apricot Phase 3, I believe, maybe Phase 4. We really got to start changing the name on those so it's not just Apricot. But I don't know, maybe Stephen was going to chuckle there. But we, as part of that, we had enough data to really evaluate how the Moderato Cchain dynamic fee algorithm was actually performing. And so we also decided to make a few tweaks in the AP5 release to address that. So first off there is the stability of the Cchain fee. So anyone that's really used the Cchain has probably seen that the fee can spike quite a bit from minute to minute. So if there's a surge of activity, they may see the Cchain fee increase, 10 to 40% even in some extreme scenarios. Now, the reason why this was done initially, was to be very conservative with how our dynamic fee algorithm was actually implemented, such that we would respond, or it would respond very quickly to surges in network traffic to preserve the stability of the Cchain. Now, after we collected enough data, we concluded that it was probably tuned a little too conservatively, or I should say a little too aggressively in how quickly it reacted to rises in traffic. So one thing that was tweaked in AP5 is that it is now about 66% less responsive to changes in traffic. So under the same amount of load, it should take 66% less time to rise the fee to a level that, it doesn't change in that particular case, all else equal, doesn't change like how high the fee would go with some level of traffic, but it would change how quickly it would get there. So for people that saw a surge of traffic, it may adjust less quickly. Now the big UX improvement there is if you submit a transaction right before the Cchain fee price spikes, you'll end up having to wait for the Cchain fee price to go down. So if you instead have something that increases more slowly and then you pad your fee estimate a little bit, it's going to be a much more reliable transaction inclusion experience. So that's what most people will probably see as a result of that. Now, the other thing that corresponded with that was actually which is not an upgrade related change, is the Cchain fee estimate itself. So the suggested fee that we serve, or like the APIs serve for transaction construction. Now, we also reviewed this and found that it was very aggressive, to put it mildly. So if you tried to submit a transaction to the network, it would suggest a fee price that would mean that you would get it immediately. So within 1 second or something like that, which for many users, or, in many cases was an overestimate of what it would take to get it in 1 second. And for some users may not have been totally necessary. So you may have seen fee prices surge up to like crazy numbers to actually get included when the actual base fee on the chain was much lower at that time. So the other thing that was tweaked as part of this review was how aggressive the API was in providing suggested gas prices to use during transaction construction. That was actually rolled out last week, right before Thanksgiving. So if you saw, a little bit more stable fee suggestions since then, that's why. Thankfully, we were able to tweak that without actually introducing any sort of on-chain upgrade. And because of the way that it's implemented, we can continue to tweak it as we ingest more data from the chain to understand how, the fee estimate relates with what the base fee we see on chain is. Now, the last thing I'll touch on here is more of a nuanced change, but we also feel like will have a larger impact. So in the Cchain, because block production is asynchronous, we have to have some way to prevent, or let's say not prevent, but discourage like frequent block production. Like we want to try to target some block production rate. Currently, that target rate is around 2 seconds. So if you try to produce a block quicker than every 2 seconds, the transactions in that block will need to basically cover what we call the block gas cost, which is a synthetic cost applied to the block that any transaction in that block must pay for the block to be considered valid. The reason there is basically saying if you're going to produce faster than the block, than like the target block rate, you have to pay for that abilities as a more or less a deterrent to do so. Now, previously, that block gas cost was actually included in the like dynamic fee calculation mechanism. So if you saw a ton of blocks being produced, or above, not a ton maybe, but like an above average target rate block production, you would also see the minimum gas price rise. Now, we reevaluated that and felt that that was also probably a little aggressive. And so we removed that from the actual dynamic fee calculation. So all in all, that means that you should see more stable gas prices. You should see gas prices that are more reflective of the actual activity on the chain. And then when requesting gas prices for transaction construction, they should be much more stable without hopefully impacting the UX of how quickly you can get a transaction confirmed on chain. And then lastly, we also increased the target gas limit, like the target gas usage for every 10 seconds by 50%. And the note I'll put here, and this is probably the topic of most discussion, is we view that increasing the target gas consumption for any period of time needs to go hand in hand with corresponding technical innovation or optimization. Otherwise, its effect is really just to increase the burden of being a validator on Avalanche, which we see is directly correlated with the decentralization of the network. So, with a single configuration, you could change the target gas limit from 10 or 15 million gas per 10 seconds to 1,000, or a million, depending on what you were trying to target. And you would see corresponding changes in how many validators could afford to run your network. And so I think there are some EVM compatible chains that push this on one side of it. So like a BSC, I think right now the gas limit is somewhere around 100 million gas per every 3 seconds. And I think the challenges to running the node under that sort of load have been well documented. And we feel like that targeting something like that without corresponding innovations on our side would really start to cut off a lot of people from the network, if not impact network health. So this feeds into what I'll target, or what we'll talk about after this. I've been talking here for a few minutes, but what we're targeting with different state management improvements to enable us to run at a higher target gas limit without impacting, hopefully, the stability or decentralization of the network. So that's a quick rundown of what the AP5 changes were and the real reasoning behind why we targeted many of those changes. I don't know if Stephen, you have anything else you want to add on top of that from what I had there.
No, yeah, I mean, I think you pretty thoroughly covered the gas optimizations and things like that on the Cchain side, and I already kind of talked about the P2C along with multiple atomics. So I think Apricot Phase 5 has been pretty well covered at this point. Yeah.
Yeah, so I think the one thing I'll kind of extend there is, as we think about subnets and the growth of subnets as a mechanism for horizontally scaling the Avalanche platform or the Avalanche network, really, we view it as a very likely possibility that people will start to run forks of core ETH. So basically versions of the EVM that run on top of the Avalanche Go VM specification that target very, very different approaches to gas metering. So let's say that you're trying to run a gaming subnet or something along those lines. And you say, well, we want EVM compatibility, but we're willing to make sure that the validators on the network or the subnet have massive compute, massive, very fast disk. And so we're going to target 100 or 200 million gas per 10 seconds. What the plan is really is that you would take core ETH we're working on here's an alpha leak or whatever people call it, but a simplified version of Core ETH that makes it much easier to parameterize let's say the levers that matter when building your own EVM based project, such that you can just say, hey, I want to target this gas limit, I want to target this block production rate, and I want to target this sensitivity of fees. That's all I need to specify, as well as like the token that I want to create, as well as maybe the Genesis allocation that would happen on that subnet. And then you're off to the races. So, we think that is the mechanism that will start to really enable people to experiment and use Avalanche for the trade-offs that they really care about. Now, obviously, it's the functionality of that is limited with the until we have high-powered cross-subnet transfers, because many times with an EVM, you're trying to build some sort of DeFi application or something that lets you perform interesting operations on tokens of value. But until then, there's a ton to explore and play around with using those constructs. And I'll talk about that in a second too. But I think that kind of covers at least that topic. So I think next up, we probably let's touch a little bit on what the targets are for the end of the year, at least related to the platform team, as well as what we're really concerned about. I know that there's a roadmap on the Ava Labs website that a lot of people have asked about, and how much will we actually get done before the end of the year, given the number of deliverables on there, and some of them are a little out of date. So, excuse me, I think providing a quick update there on what we're really targeting would be a good idea. I'll let you take the lead there, and then maybe I'll add a few items.
Yeah, no. So I think the some of the big focuses that we're working on for kind of the end of the year are focused on the Cchain side. So we've been working for a while on supporting Cchain fasting. So when you're first bootstrapping a node into the network, the P-chain will probably sync really quickly. The X-chain will probably sync a little less quickly, but it'll still be moderately fast. And then the C-chain will probably take a very long time. And the reason for that is because currently our only syncing mechanism is essentially a full archival sync, and that's way more intense than most people probably want. It's good for explorers and things like that, but it's not good for kind of the normal validators. So we've been kind of hard at work integrating fast syncability into our VM architecture. And so that's going to be kind of one of the core things that we're currently working on right now. And then I think in addition to that, staying on the VM side, we're also trying to kind of flesh out a couple new VM examples. I know currently our like tutorial VM is the timestamp VM, which while it is a valid VM, it really kind of glosses over a lot of the kind of interesting parts and the key things that are actually required for building your own VM. So we're kind of working on adding in some additional initial custom VMs, some of which being the alpha leak that Patrick just brought up with the new Core ETH or the simplified EVM plugin, but just adding in a couple more examples because personally, I think one of the most exciting things is when people start using Avalanche to iterate on building their own custom VMs. I think that's going to be, I think that's coming, and I think that'll be really huge for kind of the whole ecosystem. So yeah, those are a couple things on the forefront of my mind. Yeah.
Yeah, on the subnet thing, not to beat the topic to death here. This is something where I talked about one example. We have another example that I'll kind of keep up our sleeve for now. But you should expect those two very much by the end of the year, and corresponding with that, I'm excited to share that we're also going to be hosting a challenge really for teams to build their own subnet, given a variety of certain requirements. And then the teams that do so will win a substantial prize, basically for pioneering subnet development and subnet growth. Now, the specifics for that will be announced before the end of the year. But if you, I think a few weeks ago, I posted a Twitter thing where I was like, I'll give this NFT to the first person that creates a virtual machine on mainnet with 50 external validators. And I opened up my Paint app on my laptop and drew a picture of some stick figure holding a trophy. And as much as that may be encouraging or incentivize you to build a subnet, I figured I would also investigate if there was more we could add to that NFT to encourage people to do this. And I'm excited to share that we will. And I think we have a grants program which is in full swing, providing some sort of backing for people that want to build interesting things on Avalanche. But for this one, we're going to take more of a grand challenge approach, where instead of providing some amount of money for people that we think may be promising, we instead want to open it up to the entire community to build on Avalanche, and without any sort of gatekeeping from us, with some sort of limit or like some sort of base requirements that are needed to do so. So if you are working on a subnet or you're working on a virtual machine, keep that in mind as you're building. You're not building it just for naught. There are alone from just building an interesting virtual machine and running on Avalanche, there will be an incentive for doing so very soon. And so as you're planning, make sure to consider a VM that is not just a simple fork from some other existing VM, maybe something a little bit more novel, as well as making sure that you actually deploy it as a virtual machine on the mainnet or that people can interact with. And so I'll give a brief shout out here to Figment, who put out a nice article over the last week or so that I had the opportunity to contribute to. And they've already volunteered to help participate in the multi-sigs required to create these initial subnets where we don't have permissionless staking quite yet activated. So for people that want to do that and want to sort of experiment with that, I'm always available over Twitter as well as over Discord to support folks doing that. Wanted to share that before we got to the end here, just to make sure that people heard that we're online. So that's going to be great. And so obviously we'll share more information with that as soon as we finalize the last details there, as well as our few couple more reference VMs we're trying to drop by the end of the year. Now, I think, and then the last thing I'll touch there on is, like, for people that really know, as Steven mentioned, Avalanche just as the Cchain thing. We really think that having a few running virtual machines on mainnet that lets you do all sorts of different things with different custom virtual machines will really showcase the opportunity we feel like a low-level platform like Avalanche provides very uniquely, I think, in the space right now, in terms of what it requires to get started, as well as the flexibility you have to actually implement things. And the last thing we're really targeting for end of year, at least from a development focus perspective, is what we can do on the Cchain to better manage state, I guess. And so this is something that the Geth team and a lot of the other teams in the Ethereum community have been focusing on extensively and have tons of work and have tried multiple approaches over the last few years around how to better manage the Tri-E and pruning nodes from the Tri-E that are no longer required to actually validate blocks. With the current mechanisms that are used, once a Tri-E node is written to disk, it is never really cleared from disk because the reference or tracking of the usage of that node is not quite a straightforward task. So you end up having in like a pruning node case, multiple nodes that may be multiple node Tri-E nodes that may be sitting on disk that are not necessary for actually processing blocks, but are just left over from previous writes to disk. Now, the Geth team, I think in a few point releases ago, released something called offline pruning, which will iterate over a disk or basically a database volume that is currently not running in the node. So this is what we'll call offline pruning, that removes a bunch of the unused Tri-E nodes from the disk itself, which can dramatically reduce the size of the database volume that's allocated to the Cchain. However, you have to do it offline. So if you're running a validator, this would mean shutting down your node, running the script, which may take in our own testing maybe 30 minutes to 60 minutes, or maybe even longer. And so and it also requires like this additional node maintenance burden for validators. So we're investigating a few different ways we can extend that offline pruner into an online pruner. Now, much more complex than said, and I don't want to trivialize the complexity of this work, because it has been something that a lot of the Geth team has been focusing on for a long time. And so we are, exploring a few different avenues there, and are actively thinking about ways that we can better manage state, maybe using some advantages of our integration, which rely on we can provide deterministic finality, and there's a few different sort of mechanisms we can use at our disposal because of the VM wrapper approach we have that could make it a little bit more tractable of a problem for us. But anything that we come up with, if meaningful, we will share back with the rest of the EVM developer community, for their use if they so choose. But that's been another topic of our mind. And because of the complexity there, I don't want to say like, oh yeah, we'll have it done in 2 weeks, because I think that'd be pretty naive of me to do. But it's something that we're actively looking into. So on the platform side, it's really just to round it out, Cchain fast sync, some state management changes that would enable us to run at a higher target gas limit, and then really pushing out some additional custom VM reference examples. Now that does notably leave some things out for the end of the year. So I think we've talked about in multiple occasions, community governance with different sort of ability to change different system parameters. This would also preclude cross subnet interactions, which we don't see being completed by the end of the year. And this also precludes some of the Xchain epoching or Xchain fast sync things that we had also considered. Now, the one thing I'll point out there is that we have been very pleasantly surprised, as I think many of the people that have worked with Avalanche have been as well, the uptake of the Cchain in the ecosystem. And for that reason, we've spent a lot more development resources on maintaining that and improving its performance, instead of focusing on some of the other Avalanche specific optimizations that we had planned. When plans change, it's always a bummer for people that were that we're banking on certain optimizations or features for some time period, and we apologize obviously to those folks. But we take this the opportunity ahead of us very, very seriously. I think there's a ton of work to do, and through our own assessment framework, feel like the choices we've made here are going to set us up, going to set Avalanche and our ability to support Avalanche go up very well for the coming years. And I think our real focus for Q1 of next year is going to be much more so on the subnet related specific features once we achieve the stability and reliability goals we have in mind with the Cchain. So I don't know if you want to round that out, Stephen. Otherwise, I think there's a few community questions I think we can get to here.
Yeah, no, just touching briefly back on the state management side. There's been a lot of really interesting ideas, both internally and externally, on state management, and I think I'm particularly interested in playing around with some of them. And so, not to shill on the VM separation too much, but definitely we're looking at some of our kind of tutorial VMs to play around with some of these different state scaling solutions. So while some of them do apply to the EVM, some don't. I think that really like state management is a fascinating problem, and it's one that I'm ready to kind of dive in headfirst on. So I think it'll be a really cool kind of phase of work as we move forward.
I know you've talked about the stateless VM approach as well as a particular area of research, and I think that's an interesting one, as well as different approaches to how state is Merkleized too. Both of those are interesting.
Yeah, I mean Ethereum, and I don't want to talk too much about Merkle trees specifically, but like there's a million different approaches, and a lot of these kind of these scaling solutions end up using these in some sorts of ways. So like Ethereum's looking into these vertical trees. I know Bitcoin just released the masts with the Merkleized abstract syntax trees. There's like so many different like areas of like improvements here just based off of Merkleization and Merkle proofs and things like that. So yeah, really fascinated on that, and I think it'll be really cool once we kind of get some really aggressive state pruning along with some of these kind of stateless VM implementations. I'm really excited about that. I think that we're going to see some wild improvements. But yeah.
Yeah, very cool. So yeah, we will now touch on some of these questions. So I posted a tweet prior to this where I pointed down to the comment thread and said anyone that had any questions, feel free to post here. We're not going to take live questions at least right now. We've instead decided to take this sort of like pre-question approach just to give people the opportunity. We figured it'd be a lot of questions people would have, and so it'd be most fair if based on that. Going forward, this is obviously an iterative session here, and hope you've enjoyed so far what we've covered in the first one here. But obviously, feel free to comment on this post, or as well as tweet at me directly with suggestions or different ways we can do that. But going forward, I'll start to rank the questions that people have on my comments based on the number of likes or retweets they have on them. So if you have a burning question on your mind that you really want to get answered, tweet about it ahead of time underneath, when we do the next one of these, the kind of question request tweet I have so that we can prioritize it. So first step. So how will Avalanche compete with / integrate leading ETH L2 tech? So zero knowledge, Starknet, I think Optimism is on here. Probably Arbitrum too. Really like how we fit in with this layer 1, layer 2 sort of approach. Now, I'll comment on this first, and then give it to Stephen as well. The way I think about scaling on Avalanche is because of the flexibility we have with VMs. It's all about horizontal scaling. When you want to increase the load, instead of building vertically on top of a single virtual machine, like many other platforms choose to do, our approach really is to scale horizontally. So you want to have more load, spin up another subnet. You want to have more transactions, spin up another subnet. The idea is that any particular network or subset of the network has, reasonably speaking, some sort of theoretical bound on the load that it can process at any particular time. And so instead of trying to say we're going to limitlessly create, like on the primary network, this like thing where you have to run a supercomputer to actually participate in Avalanche, instead we feel like it's a more responsible or I think more interesting approach to say if you want to scale up load, you spin up additional subnets that provide that load and then convince validators to run more sophisticated hardware to support that additional load. Now, on that note, L2 is obviously a huge narrative right now in the ETH space, and for interesting reasons. Obviously it's all about fee reduction without limiting your ability to interact with the chain, and having that integrated in some way with L1 can be very useful, especially if you have some sort of composability component that lets you call from L1 to L2 or L2 to L1. And many of these projects, have to in some way rely on the L1 for some sort of fraud proof or security guarantees, so they don't have to run their own network. Now that can be very restrictive. If you're an L2, you have to have some way to abstract away your claim handling or your security proofs to an L1 that Ethereum can execute. Which obviously you hope that you'll never have to actually activate that code path, but it can be restrictive in terms of your development. And so what we view instead is that we think it's superior, I guess, to create subnets that are their own sovereign blockchains that anyone can kind of assign their own validator set to and not really have to worry about finding some way to abstract their virtual machine to be replayable on some sort of L1. Now, does that mean that L2s could not come to Avalanche? No. I mean, I think with the primary network, there's naturally, scarce resources there. People are going to want to interact with it a bunch. It would be very straightforward for some L2 to actually deploy a rollup on the C chain if they wanted to try and target, micro cent fees for transactions that may be too low for the C chain to actually target initially because of the kind of cutoff of decentralization that I mentioned before. So how will we compete? I don't view us as competing necessarily. I think that they're just different approaches to tackling the same problem. There's going to be enough demand from people in the blockchain space that will need all the scaling techniques we'll get. I think instead, think of it this way: Avalanche provides an alternative abstraction to how to scale these sort of things with maybe a slightly different trade-off with what it means for the actual implementer. And so that question I forgot to mention was from Flying Solo, was the Twitter account. So Stephen, I don't know if you have anything you want to add there. Then I'll take one more question.
Yeah, no, I just wanna like echo the sentiment of how Avalanche, like people always, will say like, oh, Avalanche is competing with Ethereum, like Ethereum's competing with Bitcoin, whatever. Like people always like to root for someone, but realistically, like, I'm personally, working because I find the tech is really cool, and I know that a lot of other people are working because they think the tech is really cool, and realistically, like we're all just kind of, working on building out this, these interoperable, networks that can allow, these permissionless compute and, all these different things. Like there's really no animosity in my mind. There's definitely people that do have animosity, but I just don't like the term compete. Like I think that we're all kind of working towards the same goal. But with that in mind, yeah, no, I definitely love keeping an open eye on kind of other projects and looking at their innovations and learning from them. Like definitely other projects, take inspirations from each other, and we're not going to be any different than that, right? Like if someone has a really cool idea, then yeah, I think that it'll definitely plug right into our VMs or whatever. So yeah.
And then the last one, there's two I'll kind of rapid fire on here, and more just kind of leave them as open questions or open things. One is, could we design a native browser extension based wallet? This is from Brickle Crypto, and to that I'll say, that's certainly a fascinating idea. Leave it there. And then any info for this is from someone, Cash is King. Any info on the next chain Ava Labs will be building a bridge for? And to that, I'll say, we are certainly interested in building bridges to other chains. I think the EVM was, it has been a great success thus far. I think yesterday we hit $7 billion on the Avalanche bridge. I think there are a few other chains, maybe ones that don't have as active of an on-chain DeFi ecosystem component, that would probably love to have the ability to participate in DeFi, that we're looking at. So we
No
are
alpha
looking.
leaks here.
It's a dev call, so like, yeah, we're interested in it for sure. But I think we're at time here, and we have some stuff at least I have some stuff I need to run to here. But want to say thanks to everyone for tuning in, and this is as Kyle mentioned at the beginning, and as already mentioned here, the first of what we hope is a continuous series of different sort of discussions around what we've been doing lately at the Ava Labs side on the engineering front. We have grand aspirations for really what we're trying to accomplish here. And there's so many things I didn't even get to cover. One of which is our NFT platform that we launched last week with the New York Islanders. So for their home opener, you could buy NFTs on Avalanche. We did this thing with Tops. Like they're constantly, working on new projects here. And I think the one superpower we have is we're never out of ideas. You can ask, you can see from Goon, or you can see from Kevin. There's just constant interesting ideas that we have the opportunity to go pursue, and we're actively hiring for people to join us. And if that's something that sounds interesting to you, or this communication or this conversation sparks some interest, feel free to reach out. I'm happy to chat with anyone that's considering something like this. We hire all around the world, and really all that matters to us is that you're a great engineer, that you're here for the right reasons. So, reach out to me if that's something that sounds interesting to you. Other than that, leave your comments on the Twitter on the Twitter post for this thing with tips and things we should consider for next time. But yeah, thanks everyone for tuning in. And Kyle, I don't know if you want to wrap it up.
Yeah. Thanks so much, Patrick and Stephen. Really great conversation. Thanks everyone for joining us. Stay tuned on our Twitter for updates on when we're going to do the next iteration of this series, and we'll be pushing out some news probably in the next few weeks around this subnet challenge that Patrick talked about. So thanks everyone for hopping on, and we will see you all in the next one. Have a great day.
Thanks everybody.
Thanks, everyone.
All right. See ya.
Bye.